Hi friends. Good morning, good afternoon, good evening, depending on the time zone you are in. My name is Vinay. I am JDE Financial's functional consultant. These past few days, I've been self-learning JDE orchestration and thought of putting an example together. So those wanting to see how it works can see it, and pursue it further. The example I have put together is about monitoring GL balances. So let's see exactly what it is. So what I'm going to do is go through these few items described here. Let's first review the goal of this instance. Then we'll dive into the solution design, see what components are used, then we'll walk through the system to review each of those components and then conclude. The goal of this entire orchestration is, given that there are sets of accounts that would always have either debit or credit balance for a given financial period, identify accounts that have an adverse balance, and then notify either via an email message or a notification. Here I have used an email message. So now let's see, how does the solution design looks like? So first, what I thought was of filtering the balances from a ledger for a fiscal period followed by an iterative process. So let's assume that we have filtered the balances records from the F0902 GL balances table. Then for each of those records, we will follow an iterative process wherein we will apply a rule to the object account if it typically is required to hold a debit or credit balance. We will then calculate the balance, determine if the balance is adverse, and then notify. So the first part will be deriving or filtering the balances. And for each of those records we will iterate a process. So that is what precisely this is. So the first section is basically a data request on F0902, depending on what company it is and so on and so forth. And then for each of those records, a process will iterate by applying rules, calculating balances, determining if the balance is adverse and then send a notification. Okay, so in detail, if you look at the orchestration that is being called, this is the data request type of service request and then it is calling on another orchestration through its connector and iterating it. So the connection to that iterative orchestration is in detail something like this and which basically does the bulk of the processing. So first, it applies the rule to accounts for which we use another data request on the chart of accounts to determine what the object is and what the description of that object is, primarily the object, so that in the next step we determine if it is required to have a credit balance, true or false. So if it is required to have a credit balance, then we validate if it is a balance sheet account or it is an income statement account. If it is a balance sheet account, then we calculate the balance in certain way. We consider the opening balance to calculate the total balance as of that period. If the account is not a balance sheet one, it obviously is an income statement one. And in that case, we calculate the balance, but we do not consider the opening balance which is brought forward from previous years. We just make the total of the periods until which during the financial year that we want to have the balance reported. So once the balance is calculated, we check if it is this part of the notice saying that these accounts are supposed to have credit balance. Now we check if the balance that is being passed on by this step, is it a positive number, which means that although you are required to have a credit balance, you have a debit balance in that account. So if it is true, then it will send a message through this particular step. If not, it will end and collect the output. This will happen for this node as well as this node. So if the account is supposed to have or is required to have a debit balance, so basically within this node. Since we are saying if it is having credit balance when it is true, obviously if it is having debit balance the condition results in false, then it follows this route and then it does the same test like it did it here. Whether it's a balance sheet account or not, if it is balance sheet account, then you consider the carried forward balance. In this case now, whether it is less than 0 and then if it is true, then send a message and if not just end the process. So a very simple kind of orchestration which demonstrates the functionalities of interconnected rules, use of standard JDE business function to calculate balances, and email notification. The orchestration components used are as follows. We are using data requests such as for example one for retrieving account balances and one for chart of accounts. Then we are using connectors. So we have this particular orchestration, and since we want to iterate on this, the way it is required to be designed is that, you create a connector for this and then use that connector in an orchestration. So you have an orchestration say level 1 orchestration, which is calling another orchestration through its connector. We are using custom requests. So in this example here, we are creating a custom request by making use of standard JDE business function B090090. And then we are using the component of messages to send out an email message. And then we are using rules. Rules are used as criteria for making decisions required at various steps. And then obviously the orchestration as component within an orchestration. We can now dive into the system and look at what each component looks like. Let us review all the components in detail now. We will begin looking at the Level 1 orchestration first. I recommend you must use a good naming convention for each orchestration component, so it would be much easier for identification, reference, and mapping. More so when the number of components is many and when the process is of high complexity. Each orchestration has at least 3 nodes. The first one is the start one, followed by one or more components like data requests, rules, custom requests, connectors etc., and the third one is end node. The start node has 3 action controls, namely, run, input and schedule. Using run control, you can execute the orchestration. The input node helps you define input parameter values to be used at the orchestration level. In this example, the inputs defined are company, subledger with default of asterisk, currency code with default value of asterisk, ledger type with default value of AA, period number, fiscal year, century with a default value of 20, account ID with a default value of asterisk, requested level of detail with a default value of 9 and add balance to YTD amount flag. The schedule control provides the functionality of defining execution schedule in a scheduler. The end node helps specify the orchestration output. So let me show you first the data request definition for the GL balances. This data request is based on account balances table F0902. It uses aggregate function and stores data in a data set variable array titled F0902rec. The filter criteria used is account ID, century, fiscal year, ledger type, and company. Each one of these filter criteria are assigned a variable name such as $sign followed by text, FY1, within braces, to hold the value of fiscal year, for example. This data request aggregates data of balance forward amount, and further filters data having opening balance not equal to 0. The data request groups data by account ID. The primary driver behind using aggregation is to avoid processing detailed balances maintained by subledger etc. Once we have defined the data request, we can preview its JSON code. So now, when executed successfully, our data request will retrieve several records per its definition. Let us now review the transformation mapping. The data request filter criteria variables are mapped to the orchestration input variables which would be provided by the user at the time of running it. For example, the orchestration input of fiscal year is passed on to as the criteria variable MN fiscal year is mapped to the variable name $sign FY1 within braces, which is assigned to the filter criteria data item of fiscal year. Now, rather than showing you the definition of connector to Level 2 orchestration included here in Level 1 orchestration, let me first show you the detailed Level 2 orchestration itself. We will come back to the connector setup after that. First things first, the input. The orchestration input is subledger, currency code, ledger type, period number, fiscal year, century, account ID, requested level of detail and the flag add balances forward to YTD amount. Now, let us review the first component, which is a data request from the chart of accounts F0901, account master table. This data request does not perform any aggregation. Also, it does not store the result in any data set variable. This data request uses the filter criteria of account ID, and returns certain information such as company, business unit, object account, subsidiary, account description, account level of detail and the post-edit code. You can preview the JSON code after you have completed configuring the data request. With this now, we have achieved our primary objective of finding out the object account so we can use it in following steps for processing. Now let us review the transformations mapping within this data request. Here we are mapping the orchestration input account ID, to the filter criteria account ID variable. The next component is a rule. Here, the system will decide if the object account is within two ranges of accounts. That is from 2100 to 2199, and from 4000 and 5999. This in functional terms would mean, if the object account is within accumulated depreciation accounts range, or within the range beginning liabilities until end of income accounts. The decision or the test is if the object is in this range or not. If it is true, it will follow one path, and if not, it will follow the other. The definition of this rule uses a small code. I researched and found that I am unable to use the standard Orchestrator Studio Simple Rule configuration functionality to achieve the if condition I needed to use in this instance. As such, I had to use a small code here. Despite being a functional consultant, with little education on Java, Groovy scripting language and research of Oracle documentation, I was able to understand the coding mechanism, and did not find it to be very difficult to understand and or implement. Also, the coding template provided enough starting material to write a simple code such as the one written here. In this case, the input is the object account. Then all that we are saying is, if my object account, which is referred to in this code as string value, is it within the ranges of accounts? If it is so, then the Boolean result to be returned is true, and if not, the default Boolean result to be returned is false. What I liked most about this part of rules component is, you can always unit test the code right at the time of authoring it. So, it is now determined if the account is supposed to have a credit balance or a debit balance. Let us review the transformations mapping in this rule. Here we have mapped the data request object account to the rule input object account variable. The next component is yet another rule, which decides if the object account is of type balance sheet or income statement. Within this component as well, a small code is used to test if the object account is within the balance sheet range of accounts or not. In other words, if the object account is less than value 5000 or not. The result is then returned by the rule, which determines the next step in the process flow. Just so you know, this rule could have been achieved without using a code. Here too, in the transformations mapping, the data request object account is mapped to the rule input object account variable. The next step uses a component type of custom request for calculating the account balance. So, if it is a balance sheet account, the balance needs to be calculated in certain manner. For this custom step we use JDE standard business function B090090 as its base. Let us review the data items this business function needs as input parameters and the ones in turn it returns. The input parameters are namely subledger, currency code, ledger type, period number, fiscal year, century, a flag to drive if the function reckons opening balance, account ID and requested level of detail. We use the default value of 9 for requested level details so that it picks a particular account only, and does not roll up balances, using account level of detail values. Also, in case of balance sheet accounts, we use a default value of Y for the flag that drives consideration of opening balance. The values returned by this custom request component are period amount, YTD balance amount, balance forward amount, prior year net posting amount and variance amount. Each of the data items returned are assigned variable names, to be used in the process later, such as MNYTD amount 1 for YTD amount, for example. The next step, which once again is a rule, to check if the balance is adverse. So, in this case, if the balance is greater than 0. Here too a small code is used wherein we say the balance amount mapped to YTD balance amount, if it is greater than 0. Please note, the code is used to keep consistency in design, and it could have been easily achieved with the simple orchestration functionality of defining rules. The test result yes or no is returned by the rule, so appropriate next step in the note is followed, that of sending an email message. In the transformations within this rule, the YTD amount is mapped to the rule variable of balance amount. The next component we can review is that of the email message. In the definition of this component, in the message design pane I have added a dummy to email address. In the subject, body fields I have entered requisite text. The body text uses variables, such as the account description mapped to the corresponding account's data request output variable, for example. Also, it includes amount variables, mapped to the corresponding variables of the custom request. We will now preview the message definition. Unfortunately, I will not be able to demo actual email message relay, since this system is not configured to send an email message outside of the instance's domain. So, to bypass the error, I configured the error handling for this component in such a way that even if this step errors out, the process need not be aborted, but continued. And, lastly, let us now quickly review the output part of this orchestration. With this now, we have completed the review of Level 2 orchestration. So, let us return to the Level 1 orchestration, from where we left off. So, the next component in Level 1 orchestration to be reviewed is the connector to orchestration Level 2. In this, all that we defined is, as to which orchestration the connector is being defined for. The transformations mapping is quite important in case of the connector here, considering that it needs to iterate over records from the dataset variable F0902rec of the balances data request. The other detailed field mappings are self-explanatory. Except for a key one, that is of the account ID. Here, the account ID from the account balances data request dataset variable is mapped to the connector account ID, which is picked up in the underlying Level 2 orchestration data request on account master F0901 table. Last but not least, let us review the output of this orchestration. With this, we have completed review of both Level 1 and Level 2 orchestrations. Now, let us come to the orchestration testing part. We will first use Level 2 orchestration to demo the debug functionality. What I like about the Orchestration Studio is the simple functionality it provides, to be able to debug and test the process flow, step by step. So let us now run the orchestration in debug mode. When you run it, you see the inputs to be entered in a tabulated manner, and entering data in each field could be time-consuming. You can, in that case, use the raw or JSON format, and keep it ready before you start testing. Then, quickly copy and paste the JSON raw input in the Data Input panel, and run the orchestration. In this instance that we are testing, the account is supposed to have a credit balance, object account value of 2106 being in the object accounts range from 2100 to 2200. As such, it will follow the flow, where the condition is true. Now, after this, the test would be if it is a balance sheet account, and that is if the value of the object account is less than 5000. If the test result is true, it would follow that path. The balance now will be calculated, and this being a balance sheet account, opening balance brought forward from the previous financial year would be considered. The amount can be validated with the data extracts of the account balances table F0902. The test in the next rule is if the amount is greater than 0 and, in this instance, it is less than 0, and so it would follow the flow defined for the false condition, and then the process will end. Now, let us review the output from Level 1 orchestration, and in the interest of time, I have already run the orchestration, and have extracted the output into MS Excel worksheet. From the result output, we will notice that only in one instance, an email message got generated that meets all the process flow conditions. With that, I conclude this presentation. Overall, I had a great experience in learning and using JDE Orchestration. I feel it would add a lot of value to JDE customers in achieving higher process efficiencies and user experience. Thank you for your time, and have a great day ahead. Wish you the best of the best.